All right, AP Physics 1. So this is the 2015 AP Physics 1 free response question. You have two spheres, sphere A and sphere B. Sphere A is dropped straight down, and sphere V is rolling to the right and then falls off of the table, but it also is moving right at the same time. So it's got an initial horizontal velocity, and it does travel a distance of d as it travels the distance h. So it does a little bit of both. This one just travels the distance h. The spheres do reach the ground at the same time, even though sphere V has more distance to cover. Air resistance is negligible, so don't worry about it. There's two dots here, and they represent spheres A and B, and they want us to draw free body diagrams of each one at the time t final over 2. So that's just where they would fall, and they'd be about half the time down. So half the time, we could just guess maybe that that one is there and this one is here. And so that's what they look like. That's about where they're at. We need to figure out what are the forces that are acting on each one. Well, if we don't worry about air drag, we know the only forces that are on each one are just mg. So we're going to go ahead and let's draw mg for the first one. So this is for sphere A. So we're just going to draw mg. We could do mag, but here we're just going to do mg. Sphere B should be exactly the same since they have the same mass and they're both affected on by gravity in the same way. It doesn't matter that one's moving to the right and the other one's moving straight down. They both should have exactly the same force of gravity acting on them. Unfortunately, this point was only 1 point, so this part was really just 1 point. For the next one, this is letter B. It says on the axis below, sketch and label the horizontal component of the velocity of sphere A and sphere V. So remember, sphere A is going straight down, sphere V is moving to the right, and it moves down like this. So the only one that really has a horizontal component is B. A is only falling straight down, so there's no left or right. So for letter A, we're just going to draw a line right along the 0 line here, and if you want to make it a little bit darker, you sure can. That wasn't very good. It needs to be right on there. So let's try this a little bit better. There we go. That's better. Label that one A. And then letter B does have a component. We're saying it's going to the right. And so right we'll say is positive since there's nothing going to be negative here. And we want to draw a straight line across also for it because that horizontal component does not change. Remember, the velocity left to right is the same. It's the velocity up and down that changes. The last thing that they want us to do is in a clear, coherent paragraph length. Does not have to be a paragraph as long as it's paragraph length. Explain why the spheres reach the ground at the same time even though they travel different distances. Include references to parts A and B. So here are some things that you want to think about when you do this one. First thing that we want to say, and I'm going to type these, make it a little bit easier to see. We need to indicate, so indicate that the difference in horizontal motion does not affect the vertical motion of the spheres. So how would we say that? So here's what we would say. We would say that didn't come out real well now, did it? We would say let's move this down a little bit here. There we go. For this one, I think what I would do is I would just say, if it's going to let me type here, we could just say, and I'll put a couple stars here, the vertical motion of the spheres is independent of the horizontal motion of the spheres. Okay, so that's 1 point. The next one is indicate that both spheres start with the same vertical velocity. And so essentially all you'd have to do is just say the original velocity and the vertical or y direction for each sphere is the same. So that one was pretty easy. Next one, we need to indicate that both spheres have the same vertical acceleration. So here we would say the acceleration in the y direction, or you could say, or the vertical acceleration is equal to the acceleration of gravity, which is 10 meters per second squared. Next thing that we need to do here is we need to indicate that the falling, indicate that falling the same height would take the same time. So here, basically what we need to do is just say, since both spheres fall the same distance, h, they both take the same amount of time to fall, since the time to fall is only dependent upon the y height. Okay, and then the last one is basically all you have to do is make no incorrect or irrelevant statements. Okay, so don't say anything wrong or say anything, and then I'm going to put this in quotes, stupid. For example, you might say both balls are made out of uranium and therefore they fall at the same rate. Okay, you would not want to say that. Even if you thought you were being funny, they probably would not think that's too funny, and they would say and you would end up missing some points. So make sure that you don't say anything goofy like that. I wouldn't draw any funny pictures of the two things falling and make them birds or anything like that. I would just, I wouldn't say anything like this at all. So make sure you don't do that. And that is actually 5 points. So you get 1 point for each one of these, and then you get an additional point for not saying anything incorrect and making sure you don't say anything irrelevant. So that is the 7 points on this problem, and that would be the end of this problem.